So what we're going to talk about today for Module 5 is what is very interesting in this topic compared to previously is from now on, we are not satisfied with only talking about one population. Because as you guys can see in some of the exercises I'm going to do today, one population is typically not enough. So previously, all we did is just single population. It just, one single population. It could talk about entire US population. And now from now on, we're going to move on to multiple populations. We're going to start with two populations first. So two populations first. And for this particular module, we are going to focus on proportions. You know that whenever we talk about proportion, we are dealing with categorical data. If we are dealing with numerical data, that's going to be average or mean problems, right? Mean problem. But for this module, it's going to be just proportion problem, two populations. Okay, so what I did here is for, as you can see for the second half of this page, I just copied the two tables in this worksheet. So there is this table consists of 4 pages. Everything on this table will be provided to you during the final exam. So that means you don't want to copy anything from this table on your note card because note card is only 5 inches by 8 inches. It's a precious space. You don't want to use that for something that will also be given to you. So the key whenever we refer to this table is to be sure you know what this is about. And when to, there are like plenty of formulas, which one to use and what those symbols mean. So this is the very, very important part. Okay, so what we are doing today is we are focusing on the very first page. I'm going to zoom in a little bit. And you can see it says, okay, I'm just going to highlight out for you. So it says categorical data here, right? You guys see categorical data. And so if you go to the next page, this is numerical data. So this is how you differentiate them. Okay, as far as the categorical data is concerned, there are 2 tables. The very first one is about estimation. So whenever we talk about estimation, that means you're working with confidence interval problem, or maybe you were asked to find a margin of error. Okay, for the second table, it's about hypothesis testing. So whenever we do hypothesis testing, we have to specify what is the null and what is the alternative. You probably have to find a test statistic and also p-value and make a conclusion, right? That's a pretty standard. Okay, so let's take a look. So I'm going to zoom in for the estimation part. You can see this table is further split into 2 parts. So the first one, there's only one P. This is dealing with one population. So there's only one population. When you move on to the second one, there are P1 and P2. That's 2 population. Wherever you have P1 and P2, your 1 may be different from my 1. So you would have to specify what is your 1 and what is your 2. So if we are comparing man versus woman, so 1 could be man and 2 might be women. And someone else might switch them, right? So it's very, very important. You have to specify what those 2 mean, right? 1 is man and 2 is women. It doesn't have to be this way. You just have to specify at the very beginning of the, when you work on this problem, you just have to write it out. 1 is man, 2 is women, or maybe 1 is Oregon, 2 is Washington, right? Okay, and so for the second column here is estimation. It gives you a bunch of formulas. Hopefully you guys you have seen those before. P bar, and this is a confidence interval. And when we are dealing with P1, P2, 2 populations, we are not estimating each one of them separately. What we are more concerned with here, is we are concerned with their difference. Difference is the key. You want to figure out what is the difference between P1 and P2. So what you're going to do is you're going to use P1 minus P2. Alternatively, you could also use P2 minus P1, but all the formulas, the 1 and 2 here, they have to be changed, they have to be switched as well, right? So we are only concerned with the difference between P1 and P2 so far, P1 minus P2. Okay, and the confidence intervals are given here. This is fairly similar to what we had before if you look carefully. Okay, very similar. So the first part, this is nothing but a point estimate, as you can see here. This is a point estimate. And the second part, this is the MOE, right? And what does the Z called? What does the Z called? Multiplier, right? Multiplier, because we are dealing with a population proportion problem, is always gonna be a Z multiplier. Okay, and the second part, which what I meant is the square root term. This is our standard error, right? It's just a more complicated version compared to what we had before. So you're gonna use the formula for estimation problem when you were asked to find confidence interval. And the second table is hypothesis testing. Okay, so when there's only one P as you have seen before, so typically the P0 here, usually the P0 is 0. But it doesn't have to be the case. You know, I want to stress here, P0 doesn't have to be 0. Some other time you may be interested in figuring out whether the proportion is 50% or not. In that case, the P0 is gonna be half, 50%, right? P0 doesn't have to be 0 all the time. It depends really on the context, depends on what you are comparing with. Okay, and the formula is you have to find a test statistic. You probably know this. You take the test earlier this week. You have to find a test statistic, which is a Z-score here, and then you're gonna find either the critical value, or you could also find the p-value, and then you're gonna make a conclusion, right? Okay, if we're dealing with two population, it's somewhat similar. Okay, so I'm gonna see what we have here is instead of P0, you have a D0 here. D0 just represents difference, you know, difference. Okay, so again, D0 can be 0, it can be half, it could be 99%, it could be 10%, you know, any number between 0 and 1, right? Okay, and this is the formula for test statistic. It's going to be a Z-score as well. You're gonna bring the D0 here, right? You're gonna bring the D0 here. Okay. The tricky part I want to emphasize, if you have already worked on the exercise, you probably know finding this one is a little bit tricky. What I meant is you have to figure out the sigma first. You have to figure out the denominator, which is the sigma first. And the sigma formula is given right here. In order to find the sigma, okay, so you can see it here, you have to figure out a P bar first. And the formula for P bar is given right here. Okay, so what I'm trying to say here is to find test statistic, you have to find a P bar first, and then you're gonna find a sigma, and then you're gonna find a Z-score. Right, so there are 3 steps here. You find the P bar, which is given right here, and then you're gonna find a sigma, and then you're gonna find a Z-score.